And this is CSC161, which is Java 2. And we are covering tonight primarily array lists and linked lists. Going to start by looking at the material that's in D2L. So let me share that screen. Okay, and you can see I've got it noted in here. As soon as I found out the date that the case was to be heard, I did put it into the D2L. So be interesting which way it goes. All right, and that's just my little intro to you. But this is what I want to take a look at. There is a text file that has the names of horse breeds in it. Was created with Notepad. That's all it takes to create a .txt file. And it's going to be read into Java. So let's take a look at this reference page that I've got here. Okay, it does give you some background where to go look and read to get extra help with this. The big thing on this is where to place the text file so that Java can find it when it runs. Now, if you're familiar with creating directory structures and have worked with those, especially in Windows for a long time, then you can tell the code exactly where it's located. Or if you leave it out, it's going to assume it's in the same folder that the Java code is in. So that's why there's a little bit of introductory here that says, okay, on my computer for this semester, 2020 fall, this is where I'm keeping the code that I developed. It's in this folder, sample code for class. Okay, now that tells me where to go look to physically place this file. All right, so it says you create a Java project called horse report and create a Java class called horses. This is what gets created for you. And I'm going to drop over to Eclipse and do that. So let me share Eclipse with you. Let's see, move this over. Okay, and now then if I can get that up and running, that would help. There we go. Okay, so new share, and I want to share my, oh, there it is. It was hidden from me. I couldn't find it. Not my inbox, but there we go. Okay, so now you're seeing this. This is code I've already created. I was playing around with some stuff for tonight, and we'll come back and look at this. Okay, so I'm going to close that out. And I'm going to create a Java project called Horse Report. So I'm going to do a new Java project. I'm going to call it Horse Report. Okay, and then click on Finish. Then I'm going to create a Java class called Horses. So I'm going to come back into this, create a Java class, call it Horses. And yes, I'll probably need a public static void main on this one. Okay, so now that I have created that, I want to go see where the files physically are on the computer and take a look at the structure of that file system on this. So once again, let me get a Windows Explorer open, and I'll share that. Okay, so here's what it looks like on mine. And if I'm looking at the code, the instructions, it says that this will be in C 2020 fall, CS161. Well, maybe it is, maybe it isn't. Let's see. And in case y'all didn't hear this earlier this week, my computer died. I had to take it back up to school, so they wiped it out and relayed in a new image, and I'm looking for everything in the world now trying to find it. Let's see. That, no. So C, and no, that's not there. That wasn't where I said it was going to be. That's for blame sure. Okay, so let me go into semesters, and now that's what it is. I did an extra layer here, 2020 fall into 161, and sample code for class. So here we're getting started on it. Okay. Now then there's other code that I have done that's laying out there, but I'm scooting that around. Hopefully y'all can still see it. Not it paused. So let me do a new share on this. Uh, this one. Okay, so should be seeing a screen now that's from our D2L shell. And it said, okay, what you're looking for is a folder, and it was in my sample code for class. That's where the thing was. So that part was right. And what I'm looking for is this kind of a layout in that. So let me take you back over, and we're looking for one called horse report. Okay, so I'll go share that again with us, so we'll see that. All right, there is my horse report. Okay, so let me double click it. And we now see within horse report, that was the horse report thing I just double clicked on. And within horse report, we're now seeing settings, binary, and source. And here's the text file. For my installation of Java, this is where you have to place it. Go find where you've got horse report, double click on horse report, and it's in this folder that you're going to place the horse information. Now, I have had some people on Macs, and especially if you're using something other than Eclipse, which you're not supposed to be, but if you are, sometimes you have to place it inside the bin file. And this is the closest thing to exe that Java gets to. So it may have to be in the bin file. For Eclipse, the same stuff that I'm using, it has to be in the horse report file. So that's where you place your file that you wish to read. So that was the first thing to make sure we had right. Okay, let me go back then to, I want this one. Okay, sharing. Okay, so there was the settings, the binary, the source, and it's within this folder that you place the horses information.txt file, and it goes here. And when you do that, then if you tell it go look for a file, this is where it looks for the file. So here's some sample code with it. We'll need scanner, we'll need IO file. Okay, so be sure you import both of those. Also, here's a very fun thing. I believe we played with exceptions 2 or 3 weeks ago. This is one of those things, when you tell it to go find the file called horseinformation.txt, then what happens if the file is not there? Well, you got a problem. And if you'll notice up here in my instructions, see, I put an S in that horses information, and down here it's horse information. So what is the correct name of the file? Well, you have to match exactly, capitalization and everything. So it's a very easy mistake to have a typo in here. It goes to find the file, that file doesn't exist. That is an error that can cause your code to crash and burn. Okay, so instead of that, we put up here on the main that this throws an exception, and we're saying, hey, there's a good chance it's not going to work. And so that lets it know, and then it'll let it shut everything down like it's supposed to. Okay, so anyway, we go tie this file object, which came from java.io. That's a type, and so I have a variable named file with a lowercase. And inside this area, which is someplace that can hold a file, I'm going to go create a new file, and here's where I'm calling the constructor. And in this constructor, I say this file, and it goes and looks in this location for that file. If it finds it, the world is great. That now becomes a file. Okay, now then, this ties the code to the file, but doesn't give it an ability to read it. Okay, so we'll need a scanner object, just like we were reading from the keyboard. Okay, well, here's a scanner object, and we're saying new scanner, but instead of tying it to system in, we're tying it to this file. And so it will start pulling information from the file, just like it was pulling from the keyboard. And we can go say, wow, this file has stuff in it. Okay, then go get a line, put that into this string called horse type. And that's the way this file was created. It's just per line, there is one breed of horse and a breed of horse and a breed of horse and that's it. That's all that's on the line. So go get the next line and then print that and keep doing that while there's more stuff in the file. And when you run out of stuff in the file, close that file and the program ends. So this little segment of code shows you how to read in a text file line by line. Question or comment through this area? Okay, so that's sample code for you. Also, you can look at listing 1215 in the book, and that gives you some discussion on the same area. All right, so that's one of the things that we're covering is how to read from a text file. And that's all the little stuff you'll need to know on that. Okay, so let's go back then and see where we are. Okay, that was reading horse information from a text file. So that was one topic. Another topic is this thing called an array list. Now, arrays are nice. They've got some problems that an array list solves for you, such as you don't have to know in advance how many elements are going to be in the array. But, well, let's just go look at it. Okay. Here's an array list. And it's kind of like an array, a power-up pill, if you know Pac-Man and Ms. Pac-Man and all that. Okay, so in this example, the horse information is entered from the keyboard and placed into an array list. Notice there's a little symbol after it, and that is a less than symbol and a greater than symbol or angle brackets, whichever way you want to call it. Now, here's where it is being used. To pull it in, it's import java.util. And just put an asterisk, and that pulls in everything that's there. Okay. Here's an array list. Now, this is made by Java and is ready in Java for you to use. But one of the things that's still true about an array, even if it's an array list, is you must know in advance what type of information is going to be held. Is it going to be integer? Is it going to be string? Is it going to be double? So when you say, I'm going to create an array list, the requirement is you must tell it an array list of what? Okay, so this is going to be an array list of strings. I'm going to call this array list horse breeds, and it's going to equal to a new array list. And notice you don't have to tell it the size. You just have to keep up with these little angle brackets in there. Okay, and once you do this, how do you add? Well, you can't use a subscript to begin with because there's nothing out there. So you just use this little command, .add, and you put in parentheses what it is you wish to add. And this is the same stuff we read out of the text file a while ago. Just pointing out, in this case, we're just pulling from, from the keyboard. We're not even at the keyboard. We're just hard coding this. Every time you run it, that's exactly what you're going to get. Okay, so now then, that you've done that, let's print, and notice all you have to say is horse breeds, and since it is an array list, it has a default print routine, and the default print routine looks like this. So we have out there Shire, Mustang, Belgian, Arabian, Shetland, and Lepizan. Okay, so that's that one. Now then, we drop down a line because I printed a blank line, and we can call sort, but you have to use collections. Don't ask me why. This is how you do it, okay? So I can say collections.sort this array list. And there's other options you can tell it, like what order and everything. But if you don't say anything other than this, it's just top to bottom or left to right, smallest to largest. And then we print it out again. So this now comes out in alphabetical order. And down here, it's talking about collections, and it says, hey, this is just a sample of the commands that can be used with array list. And you go through the collections interface to do this. Didn't we just get through with the lab about interfaces? Okay, this is a practical application of it. That since the array list is a collection, every function that a collection can do, the array list can do. But you refer to that particular version of array list because it is a collection. So you say, okay, well, you're a collection, so I want you to sort, and you give the name of what it is that you're wanting to sort, and that's all you have to do. There's more commands in figure 27 in your book, page 791 in the printed version. All right, so this is an array list. There's other commands you can delete, you can insert at certain locations, other things that you can do. Okay, so this shows you how to do an array list. The prior one showed you how to read from a disk file. So instead of doing the horsebreeds.add, you can do a loop there that goes for all of the names that are on the disk. And every time you read in a new line, you add that new line to the array list. Okay, so a second topic there with sample code. Now then, here's your exercise on it. Using the supplied colors.txt file with one word per line, and can't see it here. Let me see if I click on this, if I go to where I think I'm going to go. Yeah, here we go. Okay, so here's the supplied colors.txt file. You can just download that. After you download it, we just went through some screens that showed you where you have to put it so that it can be read by your code. Okay, and this is what's in it. So I want you to go through and print the words, one word per line, sort the array list and print the words in alphabetical order, one word per line, provide appropriate headings, and so your output should look like this. Any questions about that one? Okay, not hearing anything. So that's the first chunk that we're doing for this evening. All right, so let's go back then and pick up the rest of the chunk that we're doing for this evening. Okay, so new topic, linked lists. This is a concept that is expressed, can be expressed in Java. And when I say this is a concept, it's the same kind of concept like you're waiting in line to check out. Okay, you just formed a linked list. And you can go through the linked list, you know, as a node in the list of people waiting to be waited on, you know who is in front of you and you know who is behind you. And one of the things that really hacks off people in a hurry is if there was somebody that was behind you, sees that they've just opened up a new checkout stand, and they run over there and get in it, and they get checked out before you even get up to the counter. But that's different. The concept, though, is this linked list of people. Now, we'll also know that as a queue, and we'll cover queues at a different time. Queue is just really was a British term. It's the same thing as a line. You know, in Britain, you'd hear them say queue up, and that means form a line. So you're in a line, but this line can be looked at as linked lists. So that's kind of the concept behind it. Let's do the animation first. I want to do the animation first. All right. Does that show on your screen? And it's got, oh, can you see me circling head null and tail null? You'll give me a verbal.
Yeah, I can. Yep.
Okay.
Yep.
All right.
I can see it.
Okay. Well, that's one of the mistakes I've been making presenting in Zoom is I'm looking at it on the screen. I forget to show y'all. So I'm following up on that. Okay. So here's the idea. Let's just add one in. Let's put in a value of 25. Okay. And I'm going to insert that. Okay. So now this is the beginning of the list. This is the end of the list. Right now, there's only one item in it. Well, let's add another value into this. Let's add in 17. Okay, so to get to 25, I don't know where 25 is because we're seeing this like this, so that gives us an unfair advantage over code. Code doesn't get to see things like this. All it knows is that the head of the linked list is right here. Now, if you want more than that, then this node itself tells you where the next node is. And since this node doesn't point to anything, that's the last one. Also, it helps if you have a pointer that keeps up with where is the last one in the list. So let's put in something else here. Let's put 125. Well, how about 102? Because that's the keys I hit. Okay. All right, well, 102 is now the head of it, and this is the tail. Okay, so if we keep putting values in here, and doesn't matter how much it is. All right, if I want to know whether or not 120 is in this list, well, the only way I can tell is to go to the head and say, are you 120? No. Do you point to somebody else? Yes. Well, then go there. Okay. And then I ask again, are you 120? No. Do you point to somewhere else? Yes. Well, let's go there. Are you 120? No. Okay. Do you point to someone else? Yes. Let's go there. Are you 120? No. Do you point to someone else? Yes. Well, then let's go there. Okay. Are you 120? No. Do you point to somewhere else? No. Well, then 120 is not in the list. And that's the way these things have to be traversed. Okay. Now you can go through and remove stuff either at index or at value. So let's take the value out and let's look at indices. The indexes, just as a reminder, this index is 0. Why? Because if you go to the head of the list, you don't have to go anywhere, you're there. Okay, what about index 1? Well, starting from here, I have to move over 1. And to get to here, I have to move over 2, move over 3, move over 4. So 0 means I don't have to move over any. The index then greater than 0 says move over that many to get to where you're looking. So let's look at index 3. Well, that means I've got to move over 3 times. So I start at 0 and I move over 1, 2, 3. That's 17. And I'm going to say to delete whatever's at index 3. Well, just a second. Before I click that, what has to happen? Well, if I just wipe out 17, that entire thing, this pointer of 102 will now point to nothing, and nothing will point to 25. You've broken the chain, and that's not a good thing. Okay. Anyway, before then that I drop this off, the only thing I have to do really to get rid of it is to say 102, you no longer point to 17, 102, you point to 25. And so now then coming down through the list, there's 3, there's 55, there's 102, and there's 25, and 17 is never seen. And unless you go to the trouble, unless Java goes to the trouble of getting rid of it for you, then that becomes a memory leak because nothing points to it and it's just inaccessible memory. Okay, so this is a linked list. These are called nodes. A node always knows what follows it, whether it's another node or nothing. And I can go down to this. Now, once I get to 55, there's no going back. I don't have anything that points from 55 back to -3. Okay, so this is a forward only until you get to the end, and then you're through. I hope you accomplished what you were trying to do as you were looking through there. Okay, so let's see, let's go ahead and get rid of 17. Okay, so now then 102 points to 25. What happened to 17? Well, let's hope the Java garbage collection picked it up and made it available for use to someone else. All right, this is a linked list. All right, so the next thing up is the linked list with sample code. Okay, this takes you to just a very nice reference page. This is not my work. This is beginner's book. It was just a nice page I found when I was trying to find material for this class. Okay, so here's a linked list representation. And now then we're going from just a little arrow pointing to getting a little closer to what's actually going on. These are memory locations. Where does the linked list start? At memory location 3200. At 3200, there's the content and there's the address of the next node in the list. So the next one is at 3600. And so at 3600, there is your content, which is often called the payload. That's the reason for this being there. And then the address of the next link. There's the payload, the address of the next link. And this doesn't have to be in increasing order. The head could have pointed at 4400, which could have pointed at 3600, which could have pointed at 4000, which could have pointed at 3200. So these don't have to be in any particular order, just so long as you have the right address on this. Okay, so there's the head. Last node has the address of null, and null is a reserved word in Java, and it literally means nothing. Okay, then there's some discussion of why we do these. So if you're curious about that, you can look at that. Here's something else I want you to see. We're working with UML. See if you can read this thing. Dotted lines are implementations, which means that this is an interface. And all it does is guarantee linked list has everything that's in a, you'll hear this pronounced DEC. I call it DQ because it's Q. Anyway, and a DQ is a special form of Q, which is an extension of a collection, which is an extension of an iterable. That means a linked list is an iterable. Y'all reading this okay? I hope. That's what we just spent some time.
I'm getting it so far.
Okay. Well, this is why we spend time on the UML, because this is how Java is explained a lot. That we can do stuff here because that has the ability. Well, why can this have that ability? Because you're in the chain of inheritance. All right. So now that we're looking at that, that means in a minute, I can talk about an iterable. I can talk about a collection. Remember, we had collections.sort. This is why you can say that. And you can say, yes, I know you're a linked list, but you're also a collection. And so I can say, go to your collection parentage and pull out one of their abilities. Okay, so package, we just don't use that in here because all our stuff is so small. It's just one extra layer of stuff to mess with as far as this class goes. Okay, so here's my Java class. It's called Java Example. And main, okay, that's just standard, nothing new there. But linked list is one of the utils. And it's the same way that we had a while ago on an array list. This is a prefab, but even though it's a prefab, whenever you say you want to use it, you still have to tell it what's going to be in it, what type is going to be in it. Okay, so doing this on this side of the equal sign just simply gets you a place where you can put a linked list. And actually, it just tells you the address to start with. The linked list will wind up somewhere. And this list is just the address of where it starts. So go do your constructor, say it's going to hold strings, construct it, give it to me, and actually give me the address of where you put it. And now list points to wherever it is. Okay, so here's things we can do. We can add again. But here's a few other things we can do. We can add first, we can add last, and we can add at sub 2, which means you start at 0 and move over 2. Okay, and then this, let me show you. I've got some code on this, so let's go look at the code. Okay, got to get a few things out of the way here. Okay, go share, and I wish to share the workspace. Okay, and this is where we were just a minute ago. And all I did was create a Java project and then put a class in it so we could go look at the actual physical structures it made on the hard drive. So I'm going to close this out, and I'm going to go up here where I was experimenting with this. And this is a save change. Sure, why not? Okay. And let's open up this one. Hello, please. Thank you. All right. So this is the same code that we were just looking at. The only thing I did was change some of the names so that we were a little more politically correct. Okay. So linked list, it's going to hold string. I'm going to call it list, and that's a new linked list. There you go. Add Steve, Carrie, and Raj. Now, this is what I added in. At this point, it's going to print this out. And if you remember, these have a default print routine that prints it all in one line. And then we're going to add first Megan, and this should be then the first thing in the list. Ricky should be the last thing in the list, and we should move everything apart so that I have a new subscript 2 with Glenn in it, so it makes room for Glenn, shoving everything apart. And then I'll talk about this one after we run it here. So let's run it and see what's going on with this thing. Okay. Steve, Carrie, Raj, print what you got. Left to right, Steve, Carrie, Raj. Okay, add Megan is the first in the list. There she is, first in the list. Add Ricky is the last in the list. There Ricky is, last in the list. At 2, shove Glenn in between there. Okay, so if I look, here is 0, 1, 2. So where Carrie is now, all this should move over and make room for Glenn. Okay, so that's just using the default print. And these are some commands you can use with linked lists. Okay, now let's take a look at this. Iterator. Let me check something over here. Yeah, change what I'm sharing. Okay, here's the website we were looking at just a minute ago. And look what's in the heritage of linked list, iterable. That means that it's something that can have a subscript, but it's not just a subscript. And so far we've just made those fields of some kind, you know, an integer field, go to subscript X. Well, it turns out iterable is itself an object, and it gives you all these functions that you wish your subscript could just do for you. Well, let's take a look at that then in the code that we've got here. Okay. I'm going to declare something to be an iterator, and the same thing applies. Yeah, it's an iterator and it's going to work with something, but what's the type it's working with? It's working with strings. Okay, if it was working with ints, we'd say ints. And I'm just going to call it iterator. And the way that I create it is I go to my linked list, which is of type iterator, and I say, go find your iterator constructor, construct an iterator, and tell me where it is. I'm going to refer to it as iterator. Okay, now I can do a while loop. Iterator is an object with functions, and one of the functions is has next. So I can go to the iterator and say, wherever you're sitting right now, iterator, is there something that comes next? Do you have something next? Well, yeah, the very first one will be subscript 0. And it says, why, yes, I do. Okay, then what I would like you to do is go print out whatever comes next. And it's not the next value of iterator, it's the next thing that the iterator will be indicating in the list. Okay, so first name in the list is Megan. So the first time through the loop, that's a print and drop down a line. So I'll print Megan and drop down the line. Then I come back and say, iterator, is there anything else in the list? And the iterator says, yes, there is. Okay, whatever is next in the list, print it. And it prints Steve, drops down a line, then comes back, you got a next? Yes, I do. Okay, print it. That's Glenn, drops down the line. You got a next? Yep. Okay, that's Carrie, drops down the line. Still got a next? Yep. Okay, that's Raj, drop down the line. Still got a next? Yes, I do. Okay, that's Ricky, and drop down the line. Do you have anything next? No, I'm out. Okay, thank you. End of file. And that's how you get these printed once per line. And if you need to, you can use this code about linked list to go back up to the array list. And here is a sample code for how to print one per line. Is this coming along okay? What I need to know is, did the iterator make sense to you?
So far, yeah, I think.
Okay. If you're in a list, linked list of some kind, see array list also is in this hierarchy. We could have array list down here and you have the same heritage, the same structure for it. Okay, anything with the list then can request an iterator, and the iterator is just an intelligent subscript. It's, you can go to this subscript and say, hey, here's some things I want to ask. Let's see what some of the other things that will show up if I do this. Let me say iterator dot. Okay, here's all the things an iterator can do for you. You can do an equals. You can say for each remaining. You can find the class that's in it. You can get hash codes. Don't get excited about those. Those are not anything you can use for encryption. Has next, that's what we made use of. Next, that's what we made use of right there. And you can notify and you can remove. And if it's not a string, whatever it is, you can convert it to a string version. The weights, I haven't used those, so I couldn't tell you much about them. Okay, so this is what you get when you say something is of type list. Lists have iterators, and iterators have all these functions you can use. Now, the reason I'm stressing this is the first time I was introduced to this, the source that I was referring to and trying to learn from was horrible in their discussion of it. And so I never really caught on to what the iterator was. I could work with one, but I didn't know for sure what it was. Couldn't really. And so that's why after I fully understood this thing, I've tried to do my best when I'm introducing this to, so you know, when you see iterator, no big deal. It's just an intelligent subscript that's tied into this list, and make use of it. All right.
So it's just like checking piece after piece of what's going on, right?
That
Just
is
one
correct.
after the other after the other.
Yeah, and it's just another way of going from top to bottom through the list.
Is it
One
possible to
at a
go in
time.
reverse order?
Yes, you can. Don't ask me how to do that right now, but you didn't ask that. You asked, can you do that? Yes, you can. I'd have to look it up to remember the syntax on it. Okay. If nothing else, we could use collections and sort it in reverse order. And once it's sorted in reverse order, then you can come down through it in order, which is now reversed. So if nothing else, you can use that approach on it.
Thanks.
Mm-hmm. What else have we got? Questions on linked lists?
I actually had a question on the array list. I tried to
Okay.
download the colors.txt, but it just it prompts you to another tab where it opens a text file in a tab rather than downloading it.
Wait, where are we supposed to get the colors text file? Because I was looking at the exercise
The
as well.
color text file is inside the assignments one. It has it right there on the bottom. I just finished up while we were talking about it, and it's right in the middle of, like, you know that area where you're supposed to turn in the file at? It's right above that.
Okay, yeah, just a second and I'll get you there. Which one is it? Colors.txt that you're
Oh,
looking
okay,
for?
I see it. I
You
see
found
it
it?
now.
Okay, yeah.
Yeah.
Yeah, those don't show up over here in content, but
Yeah,
if
that's
you,
where I was looking and I didn't see
yeah,
it. I was like, where is it?
yeah, well, you actually have to go to the assignment and then it'll show it to you.
Yeah, I was just trying to download it and it wouldn't let me download.
Now, the question that was originally asked, why that's not opening correctly, I don't know. Let me change share so you're seeing what I'm seeing. Okay, what I would refer you to on that one is in the D2L, this discussion, this segment of code. Because this segment of code opens it, reads it, and prints it out. And notice that file input is also treated like we were looking at our array list and the other list. It has next with it. But if you're doing this code and it's not opening, I don't know. If it pops up a window and asks you for the file name, then that means that it's either not in the right location or it's misspelled. Okay, more questions? I like that you guys aren't wasting your time. If it's something that you understand, just go ahead and get it done while I'm yammering. Works out great. Okay, before I stop the recording, is there any other questions? No? Okay, then I'm going to go ahead and go ahead. I heard somebody.
Sorry,
No.
I thought of it right when before you said you want to stop. But for the iterator itself, right? Can we control not just how the iterator like moves, but can we control the length in which the iterator iterates? Like if you're gonna go for like 2 spaces instead of every one, or like.
Yeah, what I'm running through my mind is that list we just saw. There may be a way to do it, but I didn't see it in that list. So I'm going to go out on a limb and just say no.
Alrighty.
Now, having said that, there's bound to be a way to do it, but that you might have to work around to get that. That's one I would Google and look closely at the syntax you get. Okay. All right. If nothing else, nice long pause this time, then I will go ahead and stop the recording.